In this video we're going to be going over chemical reactions and also the concept of solubility. And this is our part 2 video inside of chemistry chapter 3. So let's get started with this video. So starting off, we're going to talk about the concept of solubility. So first of all, in our last video we talked about evidence of chemical reactions, and we said in that video if you can see a precipitate, then that has evidence that a chemical reaction has occurred. So basically, the formation of a solid or precipitate is listed as evidence of a chemical reaction. And basically a precipitate is just an insoluble solid which is formed during a reaction in solution, and that often involves ionic compounds. And this happens when solutions of ionic compounds are mixed, and then the anions and the cations are formed together to create an insoluble compound. So as we can see here in this picture, what we have is the chemical precipitation and how it occurs. So first of all, you have solutions, two different ones, and once you mix them together, then they're going to create this type of a suspension. And just remember that these are ionic compounds, and these ionic compounds are the ones that actually create the precipitate. So once you combine those two ionic compounds together, it'll create this type of a suspension. So all of the solids which is there inside of the ionic compound float around in these type of dots everywhere. And then once you let them all rest, then those particles will either float at the top or sink all the way to the bottom in like a clump. And that is what a precipitate is. And if you can see this precipitate, then that means it is evidence for chemical reactions. So moving on, we're now going to talk about the solubility of ionic compounds. So many ionic compounds are soluble in water, which means that when they dissolve, the ions separate from the crystal lattice structure and then move freely in the water. And in our previous chapter 2, so we talked about how ionic compounds have this crystal lattice structure which makes them really secure and strong. But what happens when these ionic compounds get into water, when they dissolve, then this crystal lattice structure that they have, the ions actually separate from it, and then they start moving freely in the water. So once they start moving freely in the water, they go into this suspension form. So you can see that they separated from their crystal lattice and now they're moving freely. And however, just keep in mind that some ionic compounds do not dissolve well, but in most cases you can find that ionic compounds will dissolve well and also have a precipitate with it. So moving on, now we're going to talk about the precipitation process. So the resulting solution becomes cloudy, and the precipitate may collect at the surface or at the bottom of the liquid. So as we said in our previous slide, the precipitate here can either sink all the way down, just like this one here in this picture, and it's just like a clump of just solid, or it could also be floating at the top of the liquid, and it is still a precipitate in that case as well. And the resulting solution here becomes cloudy, as we said over there. And this is seen as a visual sign of precipitation. So now, since we have the concept of what solubility is and also precipitation, we're going to go over some real examples and also some observations. So we're going to say that you mixed two different solutions of sodium phosphate and also calcium chloride. So we have these two different solutions. So our job is to write the names and formulas of the ions in the sodium phosphate solution. And then basically, that's all we have to do. And to do this, if we look at the sodium phosphate, so we're not going to do the calcium chloride just yet, but for sodium phosphate, so the ions that are present in this solution is the sodium ions, which is Na+, and then phosphate ions, which is PO4 3-. So in this case, the sodium has a +1 charge and the phosphate ions have a -3 charge. And for the calcium chloride solution, the ions that are present are the calcium ions, which is Ca2+, and then the chloride ions, which is Cl-. So in this case, the calcium ions have a 2+ charge and the chlorine ions have a -1 charge. So when the solutions of sodium phosphate and also the calcium chloride are mixed, what will happen? And just to recall, sodium phosphate is Na3PO4 and calcium chloride is CaCl2. So once these two are mixed, what will actually happen? So we're going to look at the chemical formula for once they actually combine together. So we have here calcium chloride, which is CaCl2 plus sodium phosphate Na3PO4, and this resulting solution, once we combine them, will turn into this here. So in this case we have Ca3, which means that there is 3 calcium ions, and in this case we have PO4 and then in bracket 2, which means that there is 2 phosphate ions. And then we also have plus NaCl, and there is no extra atoms because those two perfectly combine together. So in this case, calcium phosphate, which is Ca3PO42, it is insoluble in water, and it's going to form a precipitate out of the solution as a solid. So this precipitate down here would be the calcium phosphate, and then NaCl, which would be sodium chloride. Once we already know that once it dissolves inside of water, it's going to evenly spread out. So the resulting solution is sodium chloride, and then the precipitate is calcium phosphate. So now moving on to our next slide. So in this case, why does phosphate have the ion charge of -3? And this is because if we look at the valence electrons of both, phosphorus has 5 valence electrons, and each single oxygen wants to gain 2 electrons to fill its valence shell. So we basically have 5 valence electrons from phosphorus, and then -8 from the 4 different oxygen atoms. And once we combine those two together, then we get a charge of -3 for phosphate ion. And if we look at the formula for Ca3PO42, which is calcium phosphate, why does it have a suffix of 2 inside of the PO4? So if we look in calcium phosphate, each phosphate ion has a charge of -3, and each calcium charge has a +2. So the total charge contributed by the phosphate ions is 2 times -3, which is -6, and then the total charge contributed by the calcium ions is +6. So this case, it balances out. So since we have those 2 different phosphate ions, we get a -6 charge, and then we also get a +6 charge from the calcium ions. So that's why it is neutral. And now for balancing the equation, when solutions of sodium phosphate, which is NaPO4, and also calcium chloride, which is CaCl2, are mixed, what will actually happen? So since we already seen this before, we have calcium chloride plus sodium phosphate, as we've seen before, and then that turns into calcium phosphate plus sodium chloride, as we saw this in our previous slides. So basically now what we need to do is actually balance it. So in this case, this is not the balanced equation. So in order to balance it, you just have to guess and test a little bit, and then from there you're going to actually get your values from there on. So for example, here this is the actual equation once it's balanced for the reaction. So here what we can see here on the right side, you always look there first because it is the solution, so it's the product, and we need to balance it out with the reactants. So here we have calcium, and there's 3 of them. So since there's 3 calciums here, we're going to add a coefficient of 3 in front of the calcium chloride over here. So since there's 3 here and 3 here, the calciums are balanced, and since we added 3 here as a coefficient for the chloride as well, so that means that there's going to be 6 chlorides. So since there's 6 here, that's why we're going to add 6 in the front of the sodium chloride. And now since we added 6 here in front of sodium chloride, then that means we need to add a little bit more to the sodium over here since there's 3. So since there's 3 in the sodium, we're just going to add a suffix of 2, and that makes 6. And now since we have this coefficient of 2 here in the front, then that means we need to have 2 of these phosphate ions. So that's why we add 2 phosphates, and that balances out the equation. So this is also how you can balance equations. So basically, the calcium phosphate, which is CaPO42, is insoluble in water, and it will form a precipitate out of the solution as a solid. So now to conclude and apply, potassium nitrate, which is KNO3, is highly soluble in water. So if you mixed each of the following pairs of solutions, would a precipitate form in each of them? And explain your answer. So first of all, we have the potassium phosphate and calcium nitrate. So all we're saying here is that potassium nitrate, once it's combined in water, it is highly soluble. So that means that it's going to look like this inside of this picture, as we can see here. So if we were to combine potassium phosphate and calcium nitrate, what is the resulting solution? So potassium phosphate and calcium nitrate, mixing these two would lead to the formation of a precipitate of calcium phosphate, which is Ca3PO42, which is insoluble in water. And basically here the precipitate would be calcium phosphate, and then the resulting solution would be potassium nitrate. And the reason why the resulting solution, like the water part, the cloudy water, is potassium nitrate is because, as we said up here, it is highly soluble in water. So since it's soluble, it's going to be evenly spread out throughout the whole solution. And that's why the resulting precipitate is calcium phosphate. So moving on, as the same thing as the last slide, potassium nitrate is highly soluble. So now for this case, what happens when we mix potassium chloride and sodium nitrate? So potassium chloride and sodium nitrate, it's going to form no precipitate, because all the possible products of this mixture are soluble in water. So then in this case, there's going to be no precipitate on the bottom because once you combine them, it's all going to be soluble inside of water. And potassium, sodium chloride, and nitrate ions are all going to remain in solution, and then they do not form any insoluble compounds when mixed. And same thing as the previous slide, once again, potassium nitrate is highly soluble in water. So what will happen if we combine potassium nitrate and sodium nitrate? So in this case, potassium nitrate and sodium nitrate, there's going to be no precipitation to form again, and this is because both potassium and sodium nitrate are highly soluble in water. And once you mix both of them, they're going to simply result in a solution containing potassium plus, sodium plus, and nitrate minus ions. So in this case, there's going to be no precipitation again, no precipitate again. So as a result, there is no combination of these ions that's going to result in an insoluble compound under normal conditions. So as a summary for this video, we talked about precipitation and soluble substances. We talked about observation and chemical reactions. And for our upcoming content, we're going to talk more about predicting solubility. So thank you so much for watching from Try to Be Useful, and we'll see you in our next chemistry video.